Describing the probability of an event is only one of the ways of describing its likelihood. There actually exists another way that is in fairly common use, although not as common as probabilities. We call this the odds. The odds of an event, like I said, that's another way of describing how likely an event is. But instead of just saying some number between 0 and 1, 1 being it's a certain event and 0 being it's a completely impossible event, what the odds are described as is, if we're dealing with a sample space, we'd say it's n of e over n of e complement. In other words, the number of outcomes where that event happens divided by the number of outcomes where that event did not happen. This colon here, that's just another way of writing division. When we talk about odds, for some reason people use colons to describe the division in a problem. If they say 1 to 4 odds or something like that, they would write it as 1 colon 4, even though the odds here, it's functionally the same as writing 1 divided by 4. Alright, so that's if we know the sample space. We can talk about the number of outcomes. If we don't know the sample space, we're forced to deal with the probabilities only. And you could still convert probabilities to odds by saying the probability of the event divided by the probability of its complement. So that's if you have the probability of an event. Alright, if you have a 6-sided die, find the odds of rolling an even number. Alright, so let's first define what E is. E is our rolling an even number. This is the events 2, 4, and 6. Of course, I'm using the obvious sample space here, 1, 2, 3, 4, 5, 6, just being the outcome of the die. That would be the most logical sample space here. So the event that we roll an even number is, well, you can see we just have the 3 outcomes where we had an even number. Since we're going to need it, since we're going to need E complement, I'm going to write it down here just to make sure everyone can see what it is. It's all the events that are not in E, so it's 1, 3, and 5. So that means the odds of E are, well, there's 3 events in E. Actually, let me write it like this. This is n of E over n of E complement, which is 3 over 3. Which you could write as 1, but usually we keep it, when we're writing odds, we keep it as a ratio. You would call these 1-to-1 odds. Sometimes, you don't really need to know this vocabulary for this class, but it's helpful to, perhaps helpful in real life. These would be called even odds, and they're even odds not because it's an even number or anything like that. It's because 1 and 1 are the same number. They're equal to each other. I don't know. I don't try to understand why some of these phrases come about in real life, but we would describe those as being even odds. If we figured out the probability, of course the probability of rolling an even number is 50%. There's a 50%, that's the probability. But the odds are 1-to-1. Alright, find the odds of rolling a 3 or greater. Let's call this event F, since I just used E up there. F, this is the event of rolling 3 or greater, so 3, 4, 5, 6. I do encourage you to actually list out all of the events, especially if it's something as small as this. You might look at this and say, oh, there's only 3 outcomes there, but when you go to list them, you can see clearly there are 4 outcomes. It's really easy to get off by 1 error when you're counting things, so you need to be very careful with that. Alright, so the odds here. The odds of F would be, well, there's 4 outcomes. Actually, let me, n of F over n of F complement. That would be 4 over 2. I'll reduce that down to 2 over 1 and call this 2-to-1 odds. So you can actually see when we're talking about odds, we're not restricted between 0 and 1. You can get numbers that end up, this is equal to 2, it's bigger than 1. It turns out the larger the number, if it's 1,000,000-to-1 odds, then it's an almost certain event. You can't actually describe certain events, ones that have 100% probability. You can't actually describe those with odds. But you can say they're almost certain by saying something like 1,000,000-to-1. So if you've ever heard somebody describing something as 1,000,000-to-1 odds, that's really what's meant. Alright, so since we have 2 different forms of describing a likelihood of an event, we need to be able to convert between them. Going going from probabilities to odds, that's just using this idea up here. If we have the probability of the event, we can go from the probability of the odds just by using the probability of the event divided by the probability of its complement. The same thing we did here, except with probabilities. If we want to go from odds back to probabilities, though, then, well, let's say the odds of the event are n to m, then the probability can be found as n over n plus m. So this is a little bit of a weird way of thinking about it, but let's suppose this n and the m are between our entire sample space is split up between the event, which has a population of n, and the complement of that event, which has a population of m. Usually when we do events in this class, we do circles, don't we? So you can see our sample space would be, the size of our sample space would be n plus m in this instance. And that's why on the denominator of this fraction, we're just dividing by n plus m. So, in any case, let's do an example. If a horse is listed as having 1.56 to 1 odds, what is the associated probability? What are they? What probability of the horse winning is there, according to these odds? Well, just plugging stuff into this formula. This is my n. This is my m. So we would have 1.56 divided by 1.56 plus 1. That's 1.56 divided by 2.56. Let's pull out the calculator so I can convert this to a decimal. 1.56 divided by 2.56 gives me 0.60609,375. 6094, we'll call it. I'm just doing 4 decimal places there. You can also talk about so this is odds in favor of an event. That's the odds of the event happening. You can also talk about the odds against the event. That would actually be the odds of it not happening. So if you say the odds against the event are 3 to 2, then the odds in favor are, if you just swap them around. So the odds in favor of the event would be 2 to 3. Now that we have it written as the odds in favor, I can use this formula that I just gave you up here. 2 over 2 plus 3 is equal to 2 over 5, which would give us 0.4. So if the odds against the event are listed as 3 to 2, then that means the probability that's stating is 0.4. Suppose the probability that it will rain tomorrow is 0.8. What are the odds in favor of this event? Well, we already saw up above the odds of E are found by the probability of E divided by the probability of E complement. Well, the probability, we said, is 0.8. The probability of it not raining is 0.2. And 0.8 divided by 0.2, if you wanted to plug this into your calculator, you certainly could. 0.8 divided by 0.2 gives us 4. Which, if I write this as a fraction, it becomes 4 over 1, or 4 to 1 odds. So it's essentially 4 times as likely to rain tomorrow than to not rain. That's what an 80% probability implies. What are the odds against it? Oh, what are the odds in favor? So this is odds in favor. And if I switch them around, 1 to 4, this would be odds against. All right, so now that I've talked about how to use odds, I will go ahead and say that you do need to know how to convert from probability to odds and vice versa. That stuff is likely to show up on a test, or at least you need to know how to do it. However, you don't really need to know how to do all the rest of this stuff for this class with odds. This class is called probability in linear algebra. We focus on the probabilities of these events, and the rules when we're dealing with probabilities are a lot nicer than the rules if we were to rephrase them for odds. So that said, most of the time when you are asked for the likelihood of something, you'll be asked for the probability of that event. If I'm asking you to give the odds of the event, I will emphasize the fact that it is that I'm dealing with the odds of that event. In the question, it'll clearly say find the odds of this, and there's I'm quite likely to actually underline and maybe even bold the word odds to draw your attention to the fact, and so you don't accidentally put in the probability. I just want to make sure that you're not making that mistake. So that said, yeah, most of the time you'll be dealing with probabilities. Odds are really, they're mostly only used in gambling. That's the only place I've really seen them. If 4-to-1 odds, if one person puts in $4, the other person puts in $1, and the winner takes all, that's really where odds, that's really where they shine. If you say that they have 4-to-1 odds and you're betting for the person, you put in $4. If you're betting against them, you put $1 in. And that's really the only use that I know of with odds.